Hello, good people. Welcome to video number 3 of integration by parts, which I call UV substitution. I'm going to go back to problem number 2 because I want to show you I guess some people call it a shortcut to integration by parts, but the shortcut only works if I have a specific pair of functions and not a specific type, but a specifically behaved the way they behave is important. I'm also going to change this to u and dv instead of f and g prime. Remember, we're going to take the derivative of this and we're going to take the antiderivative of this. But the way this works is sometimes we have a pair of functions, and here's my pair, x to the fourth and sine x. We have a pair of functions where one of them cycles through its antiderivatives or derivatives. In other words, if I take the antiderivative of sine x, well, that's going to be negative cosine x. But if I take the antiderivative of negative cosine x, well, that's going to be negative sine x. And if I take the antiderivative of negative sine x, I'm going to get cosine x. And if I take the antiderivative of cosine x, I'm going to get sine x. And then it starts all over again, right? So one of the functions cycles through its antiderivatives. And the other function, the x to the fourth, if we take derivatives enough times, it's going to go down to 0, right? The first derivative would be 4x to the third, and then it would be 12x to the second, and then it'd be 24x to the first, and then it'd be 24, and then it'd be 0. So I need one function that differentiates to 0, and I need another function that cycles through its antiderivatives. That's how I'm going to use this shortcut. Because the cycling will eventually keep me coming back over and over and over again, right? So here's how we're going to do it. We're going to take my x to the fourth, and we're going to take sine x dx. Remember that in the first column, I'm going to take the derivative. Now I'm going to take the derivative until I get 0. So the derivative of x to the fourth is 4x to the third. Let me keep the colors that I used over here. So that's 4x to the third. The derivative of that would be 12x squared. The derivative of that would be 24x. The derivative of that would be 24. And the derivative of that would be 0. So I took derivatives all the way until I got to 0, which means, and by the way, that was 1, 2, 3, 4, 5 steps. So that means on this side, I'm going to have to take 5 antiderivatives. So let's start. The antiderivative of sine x is negative cosine x. So I'm kind of putting them in the same row, negative cosine x. The antiderivative of negative cosine x would be negative sine x. The antiderivative of negative sine x would be cosine x. The antiderivative of cosine x would be sine x. And then notice how the cycle begins again, and this would be negative cosine x. Great. Now, here's the neat thing about the shortcut. We're going to pair everything in the first column with things in the second column one row below. So this is going to be paired with that, with that, with that, with that, with that. So notice I'm not using the original dv and I'm not using the last u, but everything else in between I'm going to use. Additionally, this is the other thing I need to remember. My u terms are going to alternate signs. So the first one's going to be positive always, and then they're going to alternate signs. Negative, positive, negative, positive, negative. Well, but I'm not using the last one, so I don't need to worry about that. So here's the neat thing. This antiderivative that we were trying to take of x to the fourth sine x dx is equal to, we multiply across. So this would be positive x to the fourth times negative cosine x. So that's going to be negative x to the fourth cosine x. And then it's going to be negative 4x to the third times negative sine x. So that's going to be plus 4x to the third sine x. And then I multiply positive 12x squared times positive cosine x. So that's going to be plus 12x squared cosine x. And then minus or negative 24x times sine x. So that'll be negative 24 sine x. I'm sorry, negative 24x sine x. And then the last one, positive 24x times a negative cosine x, and that'll be minus 24 cosine x. So, and plus c, don't forget the plus c. So this is the antiderivative of the original x to the fourth sine x. What's really going on here is that we have to do multiple UV substitutions. But instead of reassigning and doing this process that we did in example 1 over and over and over, doing it 5 times or 4 times, I guess, it's a lot easier to use this pattern that's always going to work. So we're going to practice again. We're going to practice this process again in one of the practice problems. But again, when do we do this? We do this when one of the functions we can differentiate down to 0. If I can't go down to 0, this is not going to work. And also, we choose the other function that we can anti-differentiate over and over and over, most of the time because there's a pattern and it repeats, it cycles. But as long as I can take the antiderivative, it works. Okay, so let's try this with another one. What a boot. Oh, how about number 8? Why can I use this UV substitution using the tabular method or the tabular shortcut? Because one of the functions, if I take the derivative enough times, is going to go down to 0. And the other function, I can take the antiderivative over and over and over. It's just going to cycle and give me the same thing. All right, so let's take the derivative. The derivative of x to the third is 3x squared. The derivative of 3x squared is 6x. The derivative of 6x is 6, and the derivative of 6 is 0. And I stop. Now, take the antiderivative. The antiderivative e to the x is e to the x, e to the x, e to the x, e to the x. We're not going to use all of these. Remember, we're only multiplying diagonally. So I'm going to have 4 terms on multiplying. And then don't forget, starting with a positive term, we're going to alternate positive, negative, positive, negative. All right, so we're saying that this thing is the same thing as, or this antiderivative is x to the third e to the x minus 3x to the second times e to the x plus 6x times e to the x minus 6 times e to the x plus c. There is our antiderivative. If I do this and I actually do the product rule and figure out all these derivatives, we should get back to x to the third times e to the x. It doesn't seem like it, right? Like this is really complicated for it to just end up like this, but it turns out it does. So this is a version of integration by parts where I can use this tabular shortcut to get the answer a lot faster. Instead of identifying the u and the dv, I can just build these 2 columns, take the derivative of the first column all the way down to 0, take as many antiderivatives as I did derivatives in the first column, and then multiply diagonally, making sure to alternate signs. And that's it.